Good day, geometry. We are going over CO28 today, which is the angle bisector theorem. We've talked about an angle bisector before with Zach, and I believe CO6. What does an angle bisector do? Definition of an angle bisector. Kylie.
It splits two angles down so that it makes them converge each other.
Okay, so an angle bisector is a segment, ray, or line that divides an angle into two congruent parts. Okay? A segment, ray, or line that divides an angle into two congruent parts. Segment, ray, line that divides an angle into two congruent parts. And so the angle bisector theorem, if we have an angle here, let's kind of draw an angle out like that, okay? And you know that you have an angle bisector, right? There are two things that you know to be true, okay? The first is that, like the definition says, it divides an angle into two congruent parts. So this part and this part will be the same, okay? And similar to a perpendicular bisector, you know, a perpendicular bisector and an angle bisector are very much related because they both kind of do the same thing. A perpendicular bisector bisects a segment, and any point on the perpendicular bisector is equidistant from the ends of the segment. Remember that? Okay? An angle bisector, it divides an angle into two congruent parts, and any point that is on the angle bisector, what do you guess is the relationship? Or what do you guess it's congruent to what? A point can be congruent, but it's equidistant from the sides of the angle. Okay? Yeah. I can. Okay? And the thing about being equidistant is that we want to use perpendicular lines because the shortest distance to any place is a straight line. We're going to do this perpendicularity. Okay? What's that? Middle of what? Oh, how this, I didn't put this point in the middle of the line.
No, how can we prove that that's the middle of the
Well, the angle bisector theorem, it's already been proven. Like, we're not going to spend our time to write a proof for it.
I know, but like we should probably have to prove it. We don't really know.
This is an interesting tactic that you're employing today, Damian.
No, I'm not trying to wake up. Like,
I have a question.
We actually don't know that for sure. We have to prove it.
We don't have to because thankfully someone else already did, and that's why it's a theorem.
Yeah, well,
I mean, if you want to prove it, you take out a ruler and you measure each of those segments, and you'll see that it's true. If you want to do that again, you can do it on your own time. Sure, Joey. This
study when you said perpendicular?
What's that?
Why do you study when you said perpendicular?
Well, some people are born with brown
You
hair.
said perpendicular.
Some people are born with blue eyes. Some people are born with a speech impediment they can't control. And that would be the case for me. So that would be why. Did you listen to my answer?
Is that what you said? Yeah.
Yes, I can't control it, is what I'm saying. So what we know, folks, what we know is that these two segments are equidistant from the point on the angle bisector, and so they are congruent segments. Okay, that's the angle bisector tells us. It bisects the angle, two congruent parts, and any point that is on the angle bisector is equidistant from the sides of the angle. So, write that down. Number one, divides the angle into two congruent angles I'll move out of the way. Divides the angle into two congruent angles, and number 2, any point on the angle bisector is equidistant from the sides of the angle. I will move out of the way. I can't write on the board without standing.
Divides an angle.
Yes, divide the angle. Divides the angle.
How's that?
I'm trying to shorthand. Damien.
How's your back?
Much better today. Chiropractors do amazing work, and along with a little bit of Advil.
Were you into the chiropractor?
I did.
Which one?
My dad.
Up in Anoka. They are a sponsor of the channel, so I don't want to say their name, but if Abler Chiropractic would like to be a sponsor,
And one, they go,
the converse of the angle bisector theorem. Okay,
I didn't get it right all out.
Wait,
You
I
watch
get the,
the
I get the rest of the.
you can watch the video. Okay. The converse of the angle bisector theorem is that if you have an angle and you know that a point on the line is equidistant from the sides of the angles, or from the angle, okay, then you can conclude that it's going to be an angle bisector, right? So this is what you're given. You're given a point on a segment ray line coming from the vertex, and you see that those are equidistant, that point is equidistant from the sides. You can then conclude that it's an angle bisector. Okay? Yes?
Wouldn't that, would you also have to have the, two side, points that you just drew in between the angles, would that have to be, congruent or incongruent?
Yes, thank you. Sorry, that's the other thing I forgot. These also must be congruent. I think I said that without marking it, but yes, that is correct. Thank you. Okay? Yes, Joey.
why do we have to put the things like,
The right angles?
yeah, no, like the angles, why do they have to be like separate from each other?
Separate from each other.
Like
Oh!
red-
Oh, because I don't want you to think that I'm just making one giant arc between the two of them.
I'm not
No.
taking it.
Otherwise, it would look like this, which So, if you want to do that and you know what it means, fine. But it's better to kind of separate them a little bit, just so we can tell the difference. So, what the converse says: if a point is on a segment ray line from the vertex of an angle, and that point is distance from the sides of the angle, then the segment ray line is an angle bisector. If a point is on a segment ray or line from the vertex of an angle, and that point is equidistant from the sides of the angle, then the segment ray line is an angle bisector. So, as we've seen before, right, it's all depends on what information is given to us, and then, therefore, what can we conclude? The angle bisector theorem, if you're given those congruent angles, you can conclude the point on the angle bisector is equidistant from the sides. In this case, you're being told the point is equidistant from the sides, therefore you can conclude that it is an angle bisector. Okay? One piece of information gives you the other. Together, they tell you what an angle bisector does. Okay? Like we saw with perpendicular bisectors, what is that point of concurrency called? that middle of the triangle.
Epicenter.
For angle bisectors, it's going to be an incenter. For
Circumcenter.
circumcenter, right? And what was the relationship of the circumcenter? You need to know this for the test. A question on the test is literally, what does the circumcenter mean? Okay?
Middle of a triangle.
How is it the middle though?
Oh,
Well, yeah,
it's equidistant from the angle.
It's equidistant from the angles. Okay? And last time, Vince, around please. Legs facing forward. I had you construct the point of concurrency, right? I'm not going to have you construct the incenter. It's a little bit more complicated. Don't have time for it. But we can make 3 angle bisectors of a triangle. So I want you to, best that you can, make a triangle here. Vince, stop. Okay? And I want you to sketch, draw freehand the angle bisectors of that triangle. So coming out from each vertex, do it better than I am, draw a segment that bisects each angle. You can do a right triangle if you want to. Okay. Draw in your 3 angle bisectors. And where they intersect, that point in the middle is called an incenter. So we've got the circumcenter, which is perpendicular or equidistant from the angles. We have the incenter, which is going to be equidistant from the sides of the triangle. Okay? The incenter is the point of concurrency.
Oh, you can't do that.
The incenter is the point of concurrency of 3 angle bisectors, like we drew there. Where they intersect, that point of concurrency, we marked with that blue dot. Okay? And that blue dot is significant because that point is the middle of the triangle in the sense that it's equidistant from the sides. So this here going straight down, again, that right angle. Make a right angle with the other side of the triangle, second side. And this one's pretty close, but a right angle with the third side. Those 3 pieces will be congruent. Okay? So I said earlier that the perpendicular and the angle bisectors are similar. They both bisect something. Points on them are equidistant from something. And their points of concurrency, the perpendicular bisector equidistant from the angles, the angle bisector equidistant from the sides. Right? So they're kind of the exact opposite of each other, yet related. Yeah.
So with all of these things, what is the what are we going to use this with like proving triangles and stuff? Like what's
We're not going to use these in proofs necessarily. This is more architectural design stuff. Like we mentioned earlier, if you wanted to place a memorial between 3 significant points, buildings in your town, right? You want it equidistant from all 3 points. You'd have to calculate the perpendicular bisectors and the point of concurrency, the circumcenter, for that to happen. Okay? Statue, plaque, I don't know. Your mayor's fingerprints in the concrete, whatever it is. Yeah.
2 questions. How is this gonna help us in the real world? And
Just told you.
yeah, but I'm not gonna design.
Then it won't help you.
Okay, we don't need to listen. Why is that thing on your board?
7th graders kind of went room happy with Dwight.
Well, you should take
See, here's. Oh, anyway, we're gonna get that. Okay. So, point of concurrency in center. The thing to remember, it is equidistant from the sides of a triangle.
Why did they say cute?
Equidistant from the sides of the triangle. And there's the example there. Yes? Okay. Your homework for tomorrow is going to be on page 313. Where I put this? Here we go.
I thought she said all work.
No, it's going to be more than one. Page 313. I would like you to do numbers 3 through 8,
Even.
comma, 12 through
That's not jinxing.
17,
12 through 7.
comma, and 19 and 20. That's all.
That's
Okay.
all.
You do need to show your work before you move. Hold up. Have a seat. Have a seat. Damien, you're not listening. Lynn, you're not listening. Have a seat. If you borrow a book, it needs to be brought back every day in here. When you borrow books, I see them left on the tables. I'm not going to let you borrow books if you don't return them. And that goes with anything that you borrow, whether it be a calculator or it be loose leaf paper or whatever. Clean up your spot. Okay? Don't leave it for others to clean up. You must show your work. That's how you math. All the things.